Okay, ladies and gentlemen, for math today, you're going to need your math notebook, math workbook, and a pencil. The name of this lesson, lesson 2-8, is Round and Estimate with Decimals. After you've copied the title of the lesson, copy the learning target below. I will be able to round decimals and estimate answers to addition and subtraction problems. I will also be able to determine if an answer is reasonable based on the estimate. We're going to take a minute just to remember some things about rounding before we move on. When rounding to the nearest whole number, you should consider the following things. First, you need to identify the place value to which you are rounding. Then you look at the digit to the right of that place. If the digit to the right is 5 or more, you increase the number in the rounding place by 1. If the digit to the right is less than 5, the digit in the rounding place stays the same. Everything to the right falls off, everything to the left stays the same. We'll look at some specific examples with this. More helpful hints. Remember, it's the bossy neighbor next door to the right that tells the rounding place what to do. He says, 1 through 4, stay on the floor, 5 through 9, climb the vine. So here's an example of rounding to the nearest whole number. We are going to round, the number 4.7, 4 and 7/10. The first thing you should ask yourself is between which two whole numbers is 4 and 7/10? Well, I see the whole number 4, so then I know that it's after 4, and the number that comes after 4 is 5, so it's between 4 and 5. I'll then ask myself what number is halfway between 4 and 5. I know that halfway is always the 5th position on the number line. So then we ask ourselves, is 4 and 7/10 to the right or the left of 4 and 5/10? Well, here's 4 and 7/10. Since it's to the right of 4 and 5/10, we would say that we're rounding up to the next whole number, which is 5. This slide tells you to round each tenth between 4 and 5 to the nearest whole number. What do you notice? So here's 4, here's 5. The number line has already been broken into 10 equal-sized pieces. What we're told to do is round every single one of those tenths either to 4 or 5. We already know that the halfway point is what determines when a number gets rounded up. Anything that is halfway or further will get rounded to the next whole number, 5. So 4 and 5/10, 4 and 6/10, 4 and 7/10, 4 and 8/10, 4 and 9/10 will all get rounded up to the next whole number, which is 5. Everything to the left of 4 and 5/10 will stay at the whole number that it has just passed because it is closer to 4. 4 and 4/10, 4 and 3/10, 4 and 2/10, and 4 and 1/10 would all stay at the whole number 4. Sometimes it's helpful to use a vertical number line. Vertical number lines go straight up and down. The first question here is, if a number is greater than 3, where would it be on this number line? Well, you can first notice that the number line points up to 4. So if the number is greater than 3, it would be above 3 on the number line. It says to plot 3 and 2/10 on the number line, so we've got a point at 3 and 2/10. What whole number would it round to? Remember, halfway is 3 and 5/10. Anything that is 3 and 5/10 or above would round up to the next whole number, which is 4. Because 3 and 2/10 is below 3 and 5/10, it would stay at the whole number that it has just passed, 3. Rounding to the nearest decimal number is just like rounding to the nearest whole number. Rounding requires attention to place values in both cases. So here we're going to practice rounding to the nearest tenth. If we have the number 1 and 62/100ths, we want to figure out which tenth it is closest to. So we know that we are going to look at the tenths place that is already in this number, which is 6/10. So that means that 1 and 62 hundredths would be between 1 and 6 tenths and the next tenth, which is 1 and 7 tenths. Another way to think of that is to put an equivalent decimal, put a 0 on the end of that number to make it an equivalent decimal. Now you can see that 1 and 6 tenths is the same as 1 and 60 hundredths, and 1 and 7 tenths is the same as 1 and 70 hundredths. 62 comes between 60 and 70. When we plot 1 and 62 hundredths, we can see that it is definitely to the left of 1 and 65 hundredths, so it would stay at the tenth that we have just passed, 1 and 6 tenths. We're just going to look at some practice problems using some of the helpful hints from earlier in this presentation. When rounding to the nearest tenth, we would actually look at the bossy neighbor next door. So here's an example, 3 and 43 hundredths. If we're rounding to the nearest tenth, underline the tenths place. The 4 is in the tenths place. Since it's the bossy neighbor next door to the right that tells you what to do, we're actually going to look at 3. Remember, 1 through 4 stay on the floor. 5 through 9 climb the vine. Stay on the floor means the number stays the same. 5 through 9 means the number goes up. Since 3 falls between 1 and 4, the 3 is going to tell the 4 to stay. So the 4 stays a 4. Everything to the right falls off. Everything to the left stays the same. 3 and 43 hundredths rounded to the nearest tenth is 3 and 4 tenths. Let's take a look at another example of rounding to the nearest tenths place. Here we have 5 and 78 hundredths. If we're rounding to the nearest tenths place, underline the tenths place. The bossy neighbor next door to the right tells it what to do. An 8 comes between 5 through 9, so it's going to tell the 7 to climb. The 7 climbs up to the next number then, which is 8. Everything to the right falls off, everything to the left stays the same. 5 and 78 hundredths rounded to the nearest tenth would be 5 and 8 tenths. Let's try rounding a number to the nearest hundredths place. If we're rounding to the nearest hundredths place, we should underline the hundredths place. It's the bossy neighbor next door that tells that place what to do. A 3 comes between 1 through 4, so the 3 is going to tell the 5 to stay. The 5 stays the same. Everything to the right falls off. Everything to the left of that rounding place stays the same. If we round 3 and 53 thousandths to the nearest hundredth, our answer would be 3 and 5 hundredths. You can determine whether or not an answer is reasonable using a rounded number. Look at this example. I had $23.57. I purchased $8.79 worth of items at the store. I figured out that I have $32.36 now. Is my answer reasonable? Why or why not? Well, the first thing I notice is that I had $23.57. If I round that amount to the nearest whole dollar, I would look at the tenths place to tell me what to do. A 5 is in between 5 through 9, so it's going to tell the whole number to go up. 23 would then go up to 24. I purchased $8.79 worth of items. If I round this to the nearest whole number, I would look at the tenths place, since it's to the right of the whole number. A 7 falls between 5 through 9, so it's going to tell the 8 to go up. So I purchased $9 worth of items. I know that by purchasing something, I am spending money, which means taking away from my original amount. So I've got $24 minus $9, which leaves us with about, approximately, the little squiggly line over that equal sign means approximately, $15. Since I had figured out that it would be $32.36 now, that original calculation would not be reasonable. The reason why it's not reasonable is because $32.36 is more than the amount I originally started with and I had taken away from what I originally started with. My estimate is that I will have approximately $15 left after making those purchases. Try rounding and estimating your answers to determine if the answer is reasonable on the workbook pages 49 through 50.